Good afternoon. I'm Mena, Malak. This is Hani, Kazemzadeh, Lamy, and Nelvin, Chery. And our faculty advisor is Dr. Sabri Tosunoglu, and we will be presenting the automatic self-folding machine. On behalf of my team and I would like to thank the sponsor, Mr. Workman, for giving us the opportunity to work on this project. As for our problem statement, we were asked to build and create a machine, an automatic machine, that fold, cut, and wrap as a sub-sandwich. Our goal was to minimize waiting time and hand contact. The machine must meet all the government requirements and regulations. It must be safe, efficient, and cost-effective, as well as easy to clean and assemble. Our motivation was to gain an experience of working as a team on a project from start to end, and to see our machine in the market used in different stores. In 2014, a group of senior students have worked on this project before, and they had a very good and informative report. Yet their design couldn't do all the required tasks. Using the cigarette and the sushi roller machine, we came up with different designs that we will be discussing. For our first design, we tried to continue working on the 2014 design since we already have a prototype. The design consists of a conveyor belt and folding pads. The way that folding pads work is they are wide from the start and they are narrow at the end. So as the sandwich passes through it, it will force the sandwich to fold. We added another conveyor belt right after the first one, and we put the cutter between the two conveyor belts, so as the sandwich passes through the tunnel, the sensor will sense the sandwich and the cutter will come down and cut it. If we were to add the wrapping part to the conveyor belt, the machine would be very large in size. It will be more expensive to manufacture compared to other designs we came up with. It will be harder to clean, and the customer will have to buy a special kind of plastic wrap that they don't really use at the moment. So we did different designs.
For alternative design too, we use the grape leaf rollers, and over here the sandwich would lay down on the conveyor belt, and the movement of the shaft in the groove would fold the sandwich, and the cutter over here would cut it down. But the person who operates this machine gotta place the sandwich in a certain place and form, and the movement would squeeze the sandwich and it would get deformed.
For our proposed design, we have three shafts that is located in between a conveyor belt that's going to take the sandwich and put the paper on it and fold it with the rotating shafts inward, just as is shown in this picture here with the sushi. This is going to be the same way. The seaweed is going to fold, the rice acts like the sandwich, and the seaweed acts like the paper. And we're going to have a cutter located down at the bottom that has two actuators that's going to control this motion going up and down to cut the sandwich. As soon as it gets off the conveyor belt, it falls into the tray. Our design was inspired by a sushi roller from another design that we saw online. And the seaweed acts just as the paper would act, and the rice acts just as the sub would act, and it has 4 steps where it folds into acts like a shaft that folds the seaweed around the rice, just as the sandwich would do. And this is like a side view of the machine, and this acts like the sandwich. And we have a placeholder. This acts as a placeholder. We're going to show it in actual design. We show the front view to hold the sandwich in place while the conveyor belt is holding the sandwich inward and inward. And these are numbered parts of a lot of the integral parts of our design, where we have at 9, where we have point 9, we have the linear actuators, and we have the conveyor belt located there, the sub tray at 10. We have the sidewalls to keep everything in place and in order, as well as point 5, which is going to be it has links located on it so that it's going to move and rotate around the conveyor belt to hold the sandwich in place where it's supposed to be held. And some of our design specifications that we have right now currently is that for a lot of our these, we're going to be using stainless steel 304 because that's FDA approved. And we're going to be using a conveyor belt, inline 2-ply FDA conveyor belt. which we have the information listed on it on our design report. And we're gonna, for our automated needs, since we're making an automated sandwich, you're gonna be using our Arduino platform for that. And we're gonna be using stepper motors as well for the rotating of the shafts and everything like that. And as we go on to doing more on our design, we're going to be doing fatigue analysis, stress analysis, dynamic analysis, as well as simulations to test our product.
For the standards, we use two different set of standards. FDA, Food and Drug Administration standards in Handbook of 2013. They are very specific about the materials. As Nelvin mentioned, we're going to use steel 306 for all the components used, of the metal use of the design. And the surface is supposed to be smooth and corrosion resistant, because the sandwich, a lot of people use vinegar and it will have a chemical reaction. Plus it has to be resistant to chipping and scratching, so the bacteria won't build up in the machine. As well as it has to be washable and it has to be safe for ANSI parts, and it has to follow the international standards, so the machine will be used in different countries. For global design integration, we use the standard units and use US customer units, and we are going to provide the handbook in 3 different languages, English, Spanish, and French. And the machine that we're going to design, we're going to have a low power consumption for this energy.
So for our design considerations, we have to consider all the health and safety issues that we have to deal with the machine. But first of all, the machine is making us a product that will be consumed by people. So the machine must be safe, made with safe materials in order to handle the food product. And also, we must house all moving parts properly and keep make sure that we don't have any sharp edges on our machine. And we plan to have a guard on our blade so that it's guarded from hands to someone who's getting the sandwich from the machine. Also, the environmental impact of the machine, as well as safety regulations and the size of the machine. Here we have the division of the responsibilities for the project to ensure that all team members are able to use their skills and talents effectively and complete the project. Here we have literature survey all the way to testing, manufacturing testing, and the presentation. And here we have the distribution of the responsibilities. And here we have our project timeline from research, brainstorming, conceptual design, technical drawings, CAD modeling, and we have design review, engineering analysis. So for our design review, this is a conceptual design. And basically, through our literature survey and basically visualizing the movements, this machine should theoretically work. But we will do a proof of concept to test this machine to ensure that it works and make revisions accordingly. So for the design experience, we got the experience of referencing prior engineering work. So as the senior team worked on this project before, and after reading the report, we see all the issues, all the that they went through and their limitations, and we seeing that we're become more realistic in our expectations for the design, and we try our best to bring the best product that we can, and also as well as time management, making sure that we meet all deadlines when designing this project, considering the time that we have for the project. Thank you. And also this machine, so our sponsor presented this product to us. It was not our idea. It was he had the vision for it, and he sees a need for this product in the market. And he's interested in licensing the product to Quiznos as well as Subway, and which it can increase the restaurant throughput. It allows theoretically will allow for sandwiches to be made at a faster rate. So the company can make more sandwiches faster, as well as this machine has the potential of being used as a household kitchen utensil. And next, for our conclusion, this machine will save time by allowing employees to work on other tasks while the machine is doing the wrapping, the cutting, the folding, as well as this machine is this machine fits standard topping bars at those restaurants. Make sure that they will easily integrate into their work place. And this machine follows all regulations set by the FDA as well as NC. Also, for our future work, we will do a proof of concept to test our machine to ensure that this machine works, and whatever doesn't work, we make our revisions accordingly. We will do finite element analysis, which is the engineering analysis that we have planned, to make sure that this machine can handle all the different real-world phenomena that can happen. Like, for example, if the machine falls, or if whatever movement that we plan to do in the machine, if it's possible, engineering the speaking wise. And here we have our team poster, and thank you for listening to our presentation. Any questions?
Please go ahead. So my biggest question, I guess, is how much is it actually going to save? Because it would be nice to know what you're actually, what you're improving. Because I can see the need for it, I just don't know what that means to me. And if you don't have any data to back up your claim, then I can just say that you're wrong and continue on my day.
Yes, you would be right. But this product was presented to us by a customer, and he sees the need for it. And basically, roughly every day, 300 million sandwiches are consumed in the U.S., and a majority of those are subs. And that's roughly one sandwich per each American. So if we could increase the rate that the sandwiches produce, we will be able to increase the amount of profit these companies are making, and I think it's a pretty good idea.
It wasn't also only about profit, it was also about cleanliness and everything like that. These hospitals, they also make subs, so this is going to be advertised to hospitals too, because a lot of times contamination happens between this person who makes the subs and handles the money, so that's also why this project was presented with that, not only to save money, but also for health reasons.
The question I have to ask is, and just make sure that you look at, is make sure you do a failure modes effects analysis on this. For all the pinch points, you've got an active cutter, you've got a motorized drive, and a whole lot of pinch points. Even if you put a box around this, if this thing gets clogged somehow, someone's going in there. And so it's got to be designed safe so that if it sees interferences, it shuts itself down, and the cutters too, so that you're not sitting in a situation where people can lose a finger with this machine.
Absolutely. We plan on working with, collaborating with various other peers and other disciplines on ways to integrate sensors into the machine to make it safer for the user.
Are you trying to make this something that a sandwich shop would use or something that a factory would use?
This would be something that a sandwich shop would use. As my colleague Mena previously mentioned, the previous design with the conveyor belt would be more appropriate for a factory, but for this machine, we decided to, it was best to make it small enough to where it would fit standard size topping bar where it could be used in a restaurant.
So as part of your design considerations, how would me ordering a sandwich with just ham versus everything on the toppings, the sizing of the sub, how would that impact your design? Have you considered, if the sub is now 2 inches wide versus 1 inch wide, if the roller is going to work or the cutter is going to be big enough?
Yeah, we thought about that. That's why we have testing. We're also we're going to be including our design, but also learning from different testing methods.
You want to do this before you test it, because once you test it, you've already made the.
Oh no, we're going to do a prototype. Also, we're proof of concept. That's what we're going to be using first, and just using that to help us with to generate more ideas for more different types of circumstances, situations that happen in this up.
So my advice is spend a little more time on the drawing board, trying to figure these things out, and use the testing to answer questions that maybe you did not consider, or as you mentioned, those surprises that were not accounted for. But try and get all of these design inputs before you even make the prototype, so you don't have to go back and make a change and make a new prototype and go back. You remove that iteration.
Yeah,
Yes. Actually, we do have the answer for your questions. The belt is flexible, so when it goes around the sandwich, regardless of the fatness of the sandwich, it would hold it. It would change it. It change the shape of the belt in order to roll the sandwich around the wrapper.
If your belt is not long enough and it doesn't deform enough, right?
No.
So
I understand.
I'm not trying to
Yes, I understand.
to crash the project. I'm just telling you, look at all these things that you have considered already, and things that you might have not thought the first time around, and try and fix those things while you have a model, while you haven't spent all this time manufacturing a project and testing it. Try and get most of the answers implemented before you go into that testing phase.
Yes, sir.
How does paper get on the machine?
The paper, I don't know if you guys are familiar with, like when you go to Subway, they put all the toppings on your sandwich and then they put it on the paper. So this paper goes, the user puts it onto the belt with the paper already. The sandwich is already on the paper.
What happens if the paper is crooked?
That's one of the few things that we have to do our proof of concept for, to test this machine to make sure that we run every possible scenario of what could happen with the sandwich. If something clogs inside the machine, if the paper gets crooked, how does it feed into the machine? So all of those will be answered before our testing, through our proof of concept, to actually test the machine to ensure that it works as intended.
Why don't you feed the paper? Feed the paper in, so you put the sandwich, now you took out that failure mode, right? One of the things you just mentioned is you want to test out what happens when the paper is crooked. So remove that variable, either put the paper in or put guides where the person can put the paper always the right way, put the sub on top, and then you just remove that failure mode out of your machine. So these are the things you need to take care of before you make your final or your prototype.
And I think one more thing is, I think you guys need to have a better understanding of what the load or the duty cycle for this machine will be, because if you don't know how many times it's going to be used in a day, you don't have a way of accurately predicting what the life of this will be. And you can say that they're making 300 million sandwiches in the US, that's fine, but that doesn't mean anything because your machine doesn't make all 300 million sandwiches. If you were designing something to that, it would be overly designed for one Subway. So I think as part of your job, you need to figure out or do a time study or something of one of these target like restaurants and figure out what exactly it means to you, so that you can figure out your core parameters, so that you can actually design something with a higher probability of success and failure.
You mentioned that this was being sponsored by a sandwich shop.
No, it's being sponsored by. He has interest in licensing the product, but he's not. He's currently speaking with those different companies, but his own personal project that he's sponsoring. He presented the idea.
So start with him and see if he can get you the data of a sandwich shop, how many sandwiches they make in a day, or I'm sure Google will tell you how many sandwiches on average a Subway shop does in a day or in a year. Figure that out from there.
Absolutely.
be shooting for more crowded areas where turnaround is faster. So this one is he wants to produce it and sell it to these individual chains.
If you get the data, then you can just do, you know,
Of
your
course,
three
of course.
standard deviations and
Right.
set a limit from this many sandwiches to this many sandwiches. This machine can, or we need to make,
Capacity is that.
and then you just set your design. That's our success criteria.
I agree. And also, before we optimize the machine, we want to make sure that we put our blinders on, we figure out how we're going to actually wrap the sandwich, actually get what we need to do before we consider all the different scenarios, and then we begin to optimize our machine to ensure that it functions according to words being used.
Okay, thank you. Thank you very much.